All right, these things we're going to talk about. It's a little bit more proofs, but it's a completely different style of proof. Okay, they are called coordinate proofs. What do you know about coordinates? What do you think of when you think of coordinates?
Points on the graph.
Yeah, good. Ordered pairs, points on a graph. Very good. Okay, that's coordinated. I don't think anything coordinates with that sweatshirt, Michael. I don't think anything coordinates with that sweatshirt you got on. Jeans, that's about it.
That was a really bad joke.
All right, so here we go. We got coordinate. All right, so coordinate proofs, a little bit different. So we are going to use points on a graph. And let's give me a different color right here. Let's start off. What we're going to do is this. It's actually they're called triangles in coordinate proofs. So we're going to deal with triangles here. It's hard to start this off to show you exactly what we're going to do without just doing one. I don't know. What's the book say? I hardly read stuff right from the book, don't I? It says coordinate proofs use figures in the coordinate plane and algebra to prove geometric concepts. The first step in a coordinate proof is placing the figure on a coordinate plane. So that's what we're going to do. So first thing we're going to do is that's why I got the x and y axis right here. We're going to put a triangle on this x and y axis. Now they give you now you could put a triangle anywhere on here, couldn't you? I mean, you could put a triangle like right here, right here, right here, all kinds of places, right? You could put a triangle on a coordinate plane. But we're going to be a little bit more specific because it makes it a lot easier if you do it a certain way in order to do these proofs. Now, these aren't going to be like regular two-column proofs and you put reasons and all that kind of stuff. This is a different style of proof. Some people like these better and some people don't. I don't know. Just depends on your preference. So what I'm going to do, let's make this, I don't know if I like them better or not, but they're a little different than what you're used to, but I don't think they're that hard. So what we're going to do is make a triangle. Now, you have a little list on page 301 at the bottom, okay? And this is kind of like a little helpful hint on how to draw your triangles. Let's look at step 1. It says use the origin as a vertex or center of the triangle. So the origin is going to be an important part, okay? Then it also says place at least one side of the triangle on an axis, either on the y-axis or the x-axis, or sometimes it might be both. All right, so let's do this. Put one about like right there. Okay, so there's two sides. Do you see that? It's in color. You see the x and y axis though. But you can make a triangle out of it by connecting from there to there. All right, so is the origin one of the vertices of my triangle? Yes or no? Yes, absolutely. It's right there. Okay, that's a vertex of my triangle. Are at least one of the sides of my triangle on an axis? Absolutely. In fact, two of them are, aren't they? Okay, so that's good. Look at step 3. What's it say? Keep the triangle within the first quadrant if possible. Well, is my triangle within the first quadrant? Yeah, okay. Now, sometimes you might go to the second quadrant, but in order to just kind of not have to deal with negative numbers, sometimes it's just a little easier to keep stuff in the first quadrant because they're both positive. Agreed? And then, number 4, step 4 says, use coordinates that make computations as simple as possible. Okay, we'll talk about that in a second. So let's name these points right here. Let's go to yellow. It's a little brighter. What about this point right here? We're not even going to name it by letters. Just name the coordinate of the point. Caitlin, what'd you say? 0, 0. Yeah. So let's call this. We'll just write it right there. 0, 0. So that would be that point right there. Okay. But we got to call this point something, don't we? So what we could do, now it goes over. Now I'm not really sure how far. I didn't put little grid marks here, did I? I didn't say how far over it was, but it's over a certain distance, but then it's what? Up and down 0. So we know at least one point. What would the one point, or the one part of this coordinate be? It'd be 0, right? So it's something 0, isn't it? We could use x, we could use y, we could use anything, but when we go along the x-axis, I'm going to use A. Is that all right? So this point right here would be A0. Now, I don't know how far A is because A could be anywhere along this x-axis. Would you agree? So I just used A just to represent a certain length. Make sense? Okay, what about this point up here? What do you think I'll call this point up here? Okay, it's going to be 0 something, right? Yeah, let's use another letter. B sounds good because we've already used A. Yeah, and it's on the y-axis and all that kind of stuff. Yeah, B is the y-intercept. Perfect. Yep. All right, so that would be a nice point right there. So that's kind of how we start off with these things. All right, so it's always nice if you start them off. What if we were to write a isosceles right triangle? So let's change this up a little bit. I'll tell you what, let's do this. Let me see if I can copy and paste so we can just do a second one. There we go. Alright, how about that? Now, let's do this. Let's make this look a little bit more, it doesn't have to be identical, but does that look a little bit more isosceles?
Yeah.
Maybe a little bit more. Scooch it in a little bit more. You think?
Yeah.
Oh, really? I could do this. Watch this. I could make it exact. Boom, copy that, and then I'll do this, rotate it, what, 90 degrees? There we go. So let's get rid of this one. What's that? Oh, I don't know. Oh, yes. So, yeah. So it is shorter, isn't it? It's not longer. So I was right making it a little bit shorter. Okay, yeah, that looks good. Okay, so now watch. Now, if this is isosceles, oops, let's make it, watch this. If this is isosceles, it's this side and this side are ones that I made equal to each other, agreed? So let's label the points again. All right, so that's still going to be 0, 0, correct? I could still make this, what? A0. But what would I make this one then? Would I make it 0B again? I would make it 0A because it's equal. Exactly right. Does that make sense? I wouldn't make it 0B because the B would kind of indicate to me that it would be a different length than A. Would you agree? But if they're the same length, watch. If this and this are the same, I went over A here, so I'm going to go up A. Would you agree? So this would be 0A. Make sense? All right. Let's think of another type. Let's see what they do here. Let's do this triangle. Oops, I copied that. Let's go back and copy this triangle again. Let's copy this, this, and let's just do one of the sides. Oopsie daisy. Let's try this again. Anyway, that's good enough. Just copy the X and Y axis. Alright, what if we did this? We'll stay with red. What if we went all the way over here like this and make that a little thicker? There we go. And what if it's an isosceles triangle? Let me do this so I get fairly close, about right there. What if I said that and that? Alright. So what if this is an isosceles triangle? But I wrote it like this. I didn't make it a right triangle, did I? Not necessarily. Because before it was definitely a right triangle. Because one of my sides was along the y-axis, the other side was along the x-axis. So it had to be a right triangle because they were perpendicular to each other. Agreed? Okay, this is not necessarily a right triangle. But it's still isosceles. It's still, those two sides are equal. So what would I call these? What would I call the coordinates of this? So this would be 0, 0 again. It's pretty obvious. What would you want to call this point right here?
0A.
You could call it 0A. Alright, that would be alright. There's nothing wrong with that. But watch what I'm going to do. If this is isosceles, where is this point? This is the midpoint of this whole thing, isn't it? It would be a little easier. Remember that very last step on those 4 steps that I said? It says use coordinates that make the computations as simple as possible. Now watch this. If I called this 2A, now why would I do that? Why would I make this 2A? What would be the reason for that, Alex? Let Alex. Alex is talking. Good.
The top point would be 2B or
Well,
AB.
how far up we go? We don't know how far up we went, right? So we'll just call it B. So how far up? it would be B. But if this is halfway in between, since I called this 2A, and the reason I called this 2A, that's right, it just makes this a little easier, doesn't it?
Yeah.
Now, if I would have called this A, what would I have to call this one? Half A, or A over 2. I wouldn't call it A. If I called this one right here, A0, then I would have had to call this what? Half of A, or A over 2. Agreed? Don't you think it's a little bit easier, though? Just calling this 2A, and then if this is halfway, calling it A. Does that make any sense?
Oh, yeah.
You could have picked this 4A, but then you would make this 2A, right? As long as this is half of this. Right. Does that make sense? Wow. That went quick. I don't think we did enough. I'll tell you what. Just give it a shot, okay? Let's give it a shot.
I thought you were going to be so nice.
All juniors, please report to the gym for 8th period. That's juniors.
Kenny, where are you going? You don't even know what you're doing. You just walked out the door.
Have the following students please come to the office. Hannah, Lee,
So it's
Austin
try as
Park,
many as you can. I bet you can do
Norval
some of
Carey,
these.
Alex Healy,
7 to 18.
Gabby Langford, and
There you
Brandon
go.
Yeager. Thank you.
Okay? So try some of
Attention
those.
seniors,
See how you
tomorrow
do.
there is no senior